How do organic remains survive decomposition to become fossils? Imagine finding a tiny bone or a piece of ancient wood and wondering how it managed to survive thousands or even millions of years. It might seem like a miracle, but there are specific reasons why some organic remains turn into fossils instead of vanishing completely. When an organism dies, it usually decomposes quickly because bacteria, fungi, and other organisms break down soft tissues. However, under certain conditions, parts of the organism can be preserved and eventually become fossils. Taphonomy, the study of how organisms decay and become fossilized, helps us understand these processes. After death, the first key step is rapid burial. If the remains are quickly covered by sediment like mud, sand, or volcanic ash, they are protected from scavengers, weather, and bacteria that cause decay. Think of it like wrapping a delicate object in a protective layer that keeps it safe from the outside world. Environments such as riverbeds, lake bottoms, and caves are common places where this can happen because they often provide quick burial conditions. Once buried, minerals dissolved in groundwater start to seep into the remains. This process is called permineralization. Minerals like silica or calcium carbonate fill the tiny pores and cavities in bones, shells, or wood. Over time, these minerals harden and turn the remains into stone, creating a detailed replica of the original structure. Sometimes, the original organic material is completely dissolved and replaced by minerals in a process called replacement. This preserves fine details, like the texture of bone or the pattern on a shell. In rare cases, organic material can survive unchanged, such as in specimens trapped in tar pits or amber, which acts like a natural preservative. Not all parts of an organism are equally likely to fossilize. Hard tissues like bones, teeth, and shells are more durable and stand a better chance of being preserved. Soft tissues like muscles or skin decay quickly and rarely fossilize unless conditions are extraordinary. Because of this, the fossil record is a selective snapshot of past life, showing mostly the hard parts that survived the decay process. Taphonomic studies in anthropology help us interpret how fossils formed. Researchers often run experiments with modern animal remains to see how different burial conditions affect decay and preservation. These experiments help distinguish natural processes from human activities like burial or scavenging. Signs like gnaw marks, weathering, or deliberate burial tell us about how the remains ended up in their final resting place. In human evolution and paleoanthropology, taphonomy is vital. It helps scientists figure out if bones were accumulated naturally by animals or if early humans played a role in their deposition. For example, the position of bones, tool marks, or evidence of scavenging can reveal behaviors and environmental conditions of our ancestors. So, the survival of organic remains into fossils depends on quick burial, protection from decay, and mineral replacement. Taphonomy studies these steps to help us piece together the stories of ancient life from fragments that have endured through time.